Hi, today we are going to take a look at this military item. So the thing is called the receiver transmitter radio, the TPX54V. It's a part of an IFF system, identification, friend or foe. You can see on that picture the complete item. It is inserted inside a kind of rack. The module I have is this one. On that side there is a large PCB. So the thing was manufactured at the beginning of the 90s, that code are 92, 93. We can see here some high frequency modules. On that side we have two identical modules. On that side there are other high frequency modules. This is the first board. And here there is a daughter board. There are some logic ICs and some transistors. All parts have military specifications. The Gen TX for transistors, 54 series for the ICs. There is a power supply input here, and we have two SMA connectors here. And we have here in the middle 50 ohms load resistor. There is here a kind of transistor, but I don't think it's a transistor. It's probably a high frequency part, maybe a high frequency amplifier or something like that. SMC 378 USA. There is here a hybrid circuit and two identical parts. That code 9321. This module is actually an oscillator. The oscillator is this part. This module is connected to this second part here, which seems to be an amplifier. And the output of this amplifier is connected to this part. There is an attenuator. There are two outputs, this one and the second one, so they give the same level, 12 dBm approximately. The frequency is 1.03 GHz. This is the receiver module of this interrogator. The frequency is 1.09 GHz. The input is here. This module is connected here on J3. So this module seems to be a duplexer. This module was connected on J1. This module seems to be a directional coupler, which permits the measurement of direct and reverse power. J2 here is connected to the antenna. And J2 here is connected probably to the power amplifier, which seems to be on the right here. The input here is connected to this bandpass filter. The output of the filter is this pin here. We can see that there is another input here. This board seems to be a test generator. I think that this input permits the test of that device. This board is a generator. We can see here the schematic diagram of this board. This is the output. It corresponds to this coaxial cable here. So we can see that there is a hybrid part here. This schematic permits to know the function of this hybrid. It's actually a mixer. So this is probably a diode mixer. This voltage is around 0.5, 0.6 volt. It is possible to have approximately 30 dB range here. So this is a Colpitts oscillator, and there is a modulation input here. It is possible to adjust the frequency using this trimmer capacitor, which is this little guy here. The output of the input filter is connected to this part, which is on the bottom side. This part is an amplifier, and the output of this amplifier is connected to this part, which is the same than this one. This is a mixer. There is here a second input, which was connected to this module. There is a frequency of 1.03 GHz at the output. So the difference is 60 MHz. It corresponds to the intermediate frequency. So the intermediate frequency is available at the output of the mixer, which is this pin here, I. The output of the mixer is connected to this board. So this is the first intermediate frequency amplifier, and the output here is connected to this coaxial cable, which is connected to this module, which is actually the intermediate frequency filter. The output of the filter is connected to that board, which is the demodulator board. We can see here the demodulator board. We can see that we have several amplifiers in cascade here. The reference was obscure. It was 5962-90782, and I found that this part is actually a part from Plessey, which is a logarithm amplifier SL521. You can see that we have the sum of 6 currents here. So we can see the current is measured using this current sense resistor. There is a temperature compensation, and this difference is fed to a differential amplifier made with this matched pair of transistors here. There is a current source for the bias of these transistors, and we can see here a comparator which permits to give a digital output corresponding to the data which is received. We can see here the frequency response of the input filter. Marker 1 is at 1.076 GHz, marker 2 at 1.10 GHz approximately. The span is 100 MHz. The center frequency is at 1.09 GHz. It is also possible to test the intermediate frequency filter. The tracking generator here is connected to the input of this filter, and I will sense with my high impedance probe here the output of the filter. The filter is centered to 60 MHz. It should be also possible to connect an oscilloscope at this output here. We can see on the scope the frequency response using the RSSI output, this voltage here. This voltage is an image of the input power in dBm applied here. For the final test, I have connected this 1.01 GHz local oscillator to the second input of the mixer, this cable here. And the antenna input here is connected to this synthesizer. The frequency is set to 1.09 GHz. Currently the level is minus 60 dBm, and we can see on the scope the demodulation output. Let's decrease the input power. Minus 70 dBm, minus 80 dBm, minus 90. The limit seems to be minus 80 dBm, approximately 22 microvolts. Because we have a logarithm detector, it is only possible to modulate with a digital signal. I will change the shape of modulation to triangle. Okay, so you can see we have on the scope a logarithm function.